All right, guys. So we are continuing sketching graphs of hyperbolic functions. So far, we have discussed the graphs of sin x, cos x, and tan x, right? So we discussed these graphs previously. So all their properties. Uh, okay. So and the tan x graph, right? So we went through the properties and what happens to the graph when x approaches positive infinity and what happens to the graph as x approaches negative infinity. So we discussed these things in the previous videos, right, guys? Okay, so now the next thing we need to do here is we need to go for the graphs of, you need to know how to sketch the graph of sech x, cos x, and cot x. Okay, okay, so guys, let's go for it. Okay, so let's go for the graph of y equals sech x. Okay, so what happens in y equals sech x? Okay, so now in this case, sech is the reciprocal of the cost graph, right? So sech is the reciprocal of cost graph. Now, unlike the shine and cost graph, okay, we can't go for a method of an averaging graph that doesn't work here, right, guys? We in the cost graph, you saw that we could, when we had ex plus e minus x over 2, you saw that we broke it down into two parts and we drew the two, I mean, the ex and e minus x graph and you took an average of that, right? But over here, it's going to be the other side, right? This is the reciprocal. So 2 over ex plus e to the power minus x because h is the reciprocal of cosh. Right, guys? So you have this. Now, in order to draw this graph, so what we do here is we are actually going to consider a few coordinates. Okay, we are going to consider a few coordinates to help us to draw the graph, and we are going to consider what happens to the graph when x approaches positive infinity, and what happens to the graph when x approaches negative infinity. So basically, we will use a few coordinates. Okay. So normally, one of the main things we do, we find the place where the graph cuts the y-axis. So what do? You set x to 0. Okay, so when x is 0. Right, guys? So let's get these values. What happens when x is 0? All right, guys. So what happens when x is 0? Okay, to this guy, 2 over ex plus e to the power minus x, or in other words, this is actually 1 over cosine. So what happens when x is 0? So you can substitute x as 0 here, or you could give in your calculator directly 1 over cos 0. Okay, so what do you get here? You could directly give it as 1 over cos 0. That's also fine. Or you could just give e to the power 2 over e to the power 0 plus e to the power negative 0. That's going to be 2 over 1 plus 1, right? So that's 2 over 2. That's going to be 1. Or you could just get the answer directly from the calculator. Right, guys? 1 divided by 1, that's 1. Okay, so you can see when x is 0, the y value is 1. So that's the first coordinate. Okay, that's one coordinate. So we have one solid coordinate. And then, guys, we also need to know what happens to the graph when x approaches positive infinity and what happens to the graph when x approaches negative infinity. Okay, so what happens? Okay, because we always check that when x approaches positive infinity, right, guys, when x approaches positive infinity, what's going to happen? Okay, so we know we are dealing with I mean, we are trying to find the y value. So what happens for 1 over cos x? So guys, I think we already know the value of cos x, right? When x approaches positive infinity, the cos x value was found, right, guys? If you go back to what we did over here, you guys can see, right? So we discussed this in the previous part. When x approaches positive infinity, we found that cos x reaches to half e to the power x, right, guys? And you know this half e to the power x, it's exponential graph. As x reaches positive infinity, this half e to the power x is actually a really large value, right? So it's a large value. That's what you need to understand here. So when x approaches positive infinity, half e to the power x. So this graph goes up and it gets really large as x approaches positive infinity. This graph goes up and you get a large, like an infinite value here. So basically, when x goes to positive infinity here, cos x reaches to positive infinity, the y value, because the y value gets really large. Right, guys? So all you need to understand here is when x goes to positive infinity, cos x goes to positive infinity as well. So what happens to sech x then? So guys, you can see, here sech is the reciprocal of cos. So 1 over an infinitely large value. 1 over 1 divided by an infinitely large value is going to limit to 0. Right, guys? So you should be familiar with this, right? So when you divide 1 by a large number, obviously 1 when you divide by an infinitely large number, it's definitely going to be limiting or close to 0. So this is something that you need to know. Okay, so I assume that you already should know this. And then you also need to check what happens to the graph when x approaches negative infinity. Okay, so what happens when x approaches negative infinity? So you can see what happens to first, what happens to cost x as x approaches negative infinity. So going back the note to what we did previously. So when x approaches negative infinity, you can see we got the cost x, the graph, it limits to half e to the power minus. So guys, you know here, I mean, if you take e to the power minus x, you can see this is the e to the power minus x graph. So as x approaches negative infinity, right? So when you go behind, you can see this graph moves up, right? So it goes up like it moves, the value, the y value gets really large. Can you guys see? As x approaches negative infinity, so half, whatever the value the y value you divide by 2, but you can see that it gets extremely large, right? So again, you can see the y value approaches I mean, y becomes a large positive figure. So basically, y becomes a positive infinity, right? So over here, when x approaches negative infinity, cos x graph approaches to a large positive y value, so positive infinity. Then what happens to set check, set cheap? The reciprocal of cosh, therefore 1 over infinite large value is going to be 0. Right, guys? So we have these values. So we have these extra points. Okay, so we are going to use these points to help us to sketch the graph. All right. And then, okay, so this is the x-axis. Okay, so then, guys, so we had 1 point when x is 0, y was 1. Okay, and then, so you can see here as x approaches positive infinity, right? So over here, the graph, the set check graph is approaching 0. Basically, y equals 0 is acting like an asymptote because it's limiting to 0, right? So the graph needs to limit, or it needs to go near the 0. And when x approaches negative infinity, so when you move to this side, right, as the graph goes to the negative infinity side, the sorry, as x values approach negative infinity, the graph or your y values are supposed to get closer and closer to 0. So guys, if you think of this, there's only one way to draw a graph so that you can pass through this point and also come near these, so basically come close to 0 as x approaches positive and negative infinity. Right, guys? So if you think of it, you can use extra points as well to help you see it. So you can see that it needs to follow this kind of shape, right? Right, guys, so it needs to follow this kind of shape. So you can see in this case, it goes through this point, and you, as you reach the positive infinity, the graph reaches closer to 0. As you reach negative infinity, the graph again reaches close to 0. So you satisfy all the conditions, right, guys? So you can always use the calculator to get some extra points in order to make sure that you got the answer, right, guys? So I can show you an extra thing here. Okay, let me show you. All right, guys. So I also did the simulation using Excel. Okay, so just to show you guys how it works. So this is how it's done. Basically, what I did here was I generated X values. Okay, so this is just generating X values as you like. So I here generate X values from -4. So keeping a gap of -0.2. So you can keep the gap as you wish. I generated values until 4. Okay, so from -4 to +4. I was using values between -4 to +4. Okay, keeping the gap, you can see here all the x values, right? And then the way you get the y values. Okay, so this is actually maybe like a method like using the calculator, but just to show you how it's done very accurate. So to get the y values, you guys can see that I've given the equation. I gave the Sechek's equation. Sechek's is 2 over e to the power x plus e to the power minus x, right, guys? So 2 over e to the power, so e is exponential here. In Excel, it's exponential. So you give the value here. My x value is -4. So I give the cell e to the power x plus e to the power negative of again the same cell. right? And then you give that, and then you just have to, just pull the arrow down, and then it automatically substitutes the x value to each person, right? So you just substitute the x value here. And then guys, I went for the graph, right? So then I went for the graph. I plotted the x and y axis together, getting these two guys, okay, together. And you can just go for the graphs, right, guys? You can go for the insert and the charts, and you can get this graph. So this is basically the way I got the graph. Okay. Okay, guys. So this is the SetCheck graph. So I hope you guys can see that how the graph. So you can test more points, right? So in order to test whether it will, move below the x-axis, you can always test extra points to see how it works, right, guys? So very easily you can simulate the graph by using Excel. Okay, so basically that's the graph of y equals set checks. All right, guys. So before moving on, you also need to know the remaining properties. Okay, so what are the properties? Basically, if we talk about the range of the graph, you can see set checks. Okay, so if you talk about the range of the set checks graph, you can see set checks is only ranging between where it's going to be bigger than zero, right? Because HX graph never reaches zero or goes below zero. It's going to be greater than zero, but it's going to be less than or equal to one. So basically, you can only solve HX graphs or HX functions as long as it's within this range, right, guys? So if you have something where you get HX equals to, for sure there are no solutions here, right, guys? Because set checks graph never reaches 2. So then you don't have solutions for set checks equals 2, right? Because the graph maximum it reaches is over 1. So you can only solve for set checks values between 0 and 1, right, guys? Okay, so this is extremely important. So you can see the graph over the entire domain of X, the range is only going to be between 0 and 1. So this is basically the graph of set check. All right, guys. So next we'll move on to the sketch of y equal cos checks, right? So guys, cos checks is 1 over sin x, right, guys? So guys, let's again go for the same process. So let's see what happens to the graph as x approaches positive infinity. What happens to the graph as x approaches negative infinity, and also what happens as x reaches 0. Now in this graph, guys. Okay, so there are a few important things to note. Okay, so the first thing is, okay, unlike the H graph, in the shine graph, okay, so if you look at the original shine graph, guys, so this is our original, this is our shine graph. Now we are trying to draw the reciprocal of this. Okay, so in this case, we run into an additional problem. Okay, so what is the additional problem? Over here, guys, now you saw when we were drawing the SHX graph, we didn't have any issue. If you check the original COSHX graph, you can see it's entirely completely above 1. Okay, so we did not so there is actually no issue here. Now the issue over here, the problem that we face over here is, guys, your original graph passes through y equals 0. Can you guys see? Your original graph passes through y equals 0. And guys, you know that we are going to take the reciprocal of this, right, guys? So if you are going to take the reciprocal of this, you need to remember, right? What happens as x approaches, you need to realize immediately that at this point, when x is 0 in the reciprocal graph at x equals 0, you are going to get an asymptote. Right, guys? Because you remember when we were discussing in P3, so we drew the tan graph and the cot graph, right? That was back then in P3. So in the tan graph, wherever the tan graph became 0, the cot graph was an asymptote at that point, right? When you took the reciprocal. So it's a similar thing here. Because the shine x graph passes through 0 here. Because of this point needs to be an asymptote in the cos x graph, in the reciprocal graph, right, guys? So that's an important thing. Okay, so basically you have an asymptote. So you realize from the beginning that x equals 0 is an asymptote in the graph, right, guys? So so you realize that the graph breaks from this point. Okay, so your graph is going to break into two at this point. Okay, so then we need to see what happens to the graph. Okay, so there's no point of using x equals 0 here, right, guys? Because you know you are going to get an asymptote. So you need to see what happens to the graph, or how the graph is behaving when the x value. Okay, so now this is your asymptote, right? So you need to see how your graph behaves close to the asymptote. So when x is approaching the asymptote from the positive side, as your x values approach the asymptote from the positive side, is the graph going to be a large positive y value, or is your graph going to give you a large negative y value? Because you know, normally when you're close to an asymptote, the graph is either a large y value or a very large negative y value, right? A large positive y or it's a large negative y. That's how it normally is, right, guys? And you need to see when the what happens to the y values as the x values approach 0 from the negative side. So as you approach the graph, or as you approach the asymptote from the negative side, are the x values, I mean, is the y value, are they going to be large and positive, or are they going to be large and negative? So that's what you have to do here. I hope you guys get what I'm talking about, right? So these are things you need to check. Okay, so once again, what happens, how does the graph behave when the when for the positive, I mean, when the positive x values reach close to 0, are your y values large and positive, or are they large and negative? Because those are the two options. You don't have any other option, right? Close to an asymptote, the values are either large and positive, or it's large and negative. That's it. Those are your two options. Okay, that's why it's an asymptote, right? Because the graph is reaching an infinitely large value near the asymptote. And then what happens to the graph on the other side, right? Because you know that on the other side, the graph, your original graph went through this one, right? So then you know the graph exists on both the sides. The Shinex graph existed on both of these sides, right, guys? So I need to see what happens to the other side. As you take the reciprocal, we need to know whether the graph, the y values are large and positive, or whether it's large and negative. So that's what we need to do now. All right, guys. So here I've done it for positive x. As x approaches 0. Okay, so I'm testing the positive x side. For with positive x values, what happens as x approaches 0? What happens to the cosine x, or what happens to our y value? Right, guys. So we know as x approaches 0. Okay, so what's going to happen here? So guys, in order to do this, I'm going to use the help of the calculator, right? Because we know the values of shine x as x approaches positive and negative infinity. So when x approaches 0 from the positive x side, okay, so as x approaches 0 from the positive x side, you guys can see what I've done here. Okay, so basically I am inputting values for the x in the shine x. Okay, so what happens to the graph as x approaches 0 from the positive x? So as it comes closer and closer to 0, guys, you can give values really close to 0, but from the positive x side. So maybe you could give 0 0.01 or 0 0.001. The closer to 0, the better, right, guys? The more closer, the better. And then, guys, you can see as you give values closer to 0, you can see you get large positive y values. You can see the more closer you get to 0, the more zeros I add, the larger it gets. Can you guys see? Can you see? So it gets larger. It gets really large. So then you understand as x approaches positive infinity, your cosine x graph, because I gave 1 over shine x there, so that's cosine x. So that approaches to positive infinity, right, guys? Because the value gets larger and larger. And then you have to also check what happens for negative x, because I want to see what happens on the other side as well. For negative x, as x approaches 0. Okay, so on the negative side, when x approaches 0, what's going to happen? So you can again use the help of your calculator, right? So over here, you have to give values very close to 0, but from the negative x side now. So let's just give a negative value here, right, guys? So minus, let's give 0.001. And you can see I get a negative answer now. Can you guys see? So the more zeros you add, the more closer you bring it to 0, you can see it gets larger. Okay. So you can see in this case, as from the negative x side, as x approaches 0, your cosine x graph approaches what? It's negative y, one large negative y value, which is negative infinity. So then It's an infinitely large negative value. All right, guys. Okay, so we got those two boundaries. Okay, so because you can see that this is an extra thing that we did not check in the other graphs. In the other graphs, we did not have this problem, right, guys? And now, guys, you also have to do the normal typical check. The typical thing we always check in every graph is what happens to the y value as x approaches the positive infinity and as x approaches negative infinity. That check also needs to be done. Okay, so we'll do that as well. So when x approaches now positive infinity, so what happens to your y? So when x approaches positive infinity, yeah, shine x. I think we already know this, right? So when x approaches positive infinity, so we already got the answer for shine x, right? When x approaches positive infinity, shine x is half e to the power x. Half e to the power x means you know that it's an infinitely large y value. It's a large y value, right? So this is positive infinity. And when x approaches negative infinity, shine x is gonna be when x approaches negative infinity. So you can see we have shine x as minus half e to the power minus x. There's a minus mark. Okay, but e to the power minus x graph. So guys, I showed it earlier also, right? E to the power minus x is this graph over here. But when you go to the negative infinity side, you can see as x goes to negative infinity, this graph also gets the y value gets really large, right? Large, and it's a positive value, but you have a minus half e to the power minus x. So the minus half in front makes these positive values all negative, right? So because of the negative half here, this minus mark ensures that your the entire thing turns to negative. So you have a negative y value and you have a negative large negative y value. So basically, what it says here is that you get a large, infinitely large negative figure. Right, guys? So these are kind of like our boundaries. So now you can see so you can see kind of like a sketch of the graph in your head, right? Hopefully. So you can see over here for positive x as x approaches 0, right? So when you come close to 0 from the positive x side, your graph y value is a large positive y figure. So you should realize that it's somewhere top over here. Right, guys? Oh, it comes from the top. As x is close to 0, the graph is the y value is at the top. So a large y value. And you can see combining this with this guy. Okay, so because you check what happens when x is close to 0 from the positive side, and you check what happens to the graph as x goes to positive infinity. So when x goes to positive infinity, oh, sorry guys. Okay, so I have written here the values of only shine x, right? So we are supposed to write the value of what? We are drawing the cosine graph, right? So let's write the value of cosine. So if shine x goes to positive infinity, what will be the cosine graph? So guys, you know cos h is the reciprocal of shine, right? So 1 over an infinitely large positive figure is going to be 0. And over here, 1 over the reciprocal of this guy, 1 over an infinitely large negative figure is also going to be 0. Right, guys? So that's all going to be 0. So you can see here. So I'm trying to draw the cosine graph. Okay. So combining these two now. So when x goes to 0 from the positive side, you have a large y figure. And when x goes to positive infinity, so that means when it's over here, the graph reaches 0. Right, guys? So you need to see that it looks a graph like this, kind of like. Okay, and you can see the same thing on the other side. For negative x, as you reach close to 0, right, you have a large negative y figure. So your graph is down over here. Right, guys, can you see? It should be down because it's a large negative y figure. And when x approaches negative infinity, so when you go to the negative infinity side, you can see your graph reaches 0. It reaches the y value 0. So you get this kind of graph. Right, guys, can you see? And y. All right, so let me show you the simulation from Excel as well. So I'm going to draw y equal All right, guys. Okay, so let's draw the, let's give the values. So I'll give again from -4 minus. So you can give the intervals as you wish. And just pull the values. All right, so this is the x values. Now let's give the y values. Okay, so we know cos x is the reciprocal of sine, right? So sine x is e to the power x minus e to the power minus x divided by 2, right, guys? So this should be the reciprocal of, that should be 2 over. So I'm taking the reciprocal of the sine graph. So you give a bracket here, the exponential. What is the exponential? E to the power x. So my x value here, you give this cell x, ex minus, right, guys? So ex minus e to the power minus x, actually, sorry. So e to the power x minus e to the power minus x. Right, guys? And you have to close the extra bracket, right? The normal sine x was ex minus e to the power minus x divided by 2. So the cos h should be the reciprocal, 2 over ex minus e to the power minus x. Actually, I didn't give the exponential here, right? Sorry, wait. This is wrong. Minus, again, this should be exponential here, right? The exponential minus x. Okay, so that this is correct. Can you see, guys? 2 over ex minus e to the power minus x. You get your answer. And then you can just pull this down. And you get all of this. So guys, over here, you can see you get the error division by 0, right? Because you can see, you saw in what we did previously, x equals 0 was an asymptote. Can you see? So that's why this gives you have an error division by 0. So I'll just remove this point, okay? Because when you draw the graph, that's just going to be a problem, okay? Okay. All right, guys. All right, guys. So then after you simulate the points and you remove the zeros, that x equals 0, you can say remove the y value. And then you select the xy values, right? And then you go to insert, and then you can go to the chart and you can select. Right, guys? I think you can clearly see how the graph looks, right? So this is the y equal cos x graph. All right, guys. So you can see that how the asymptotes and you can see everything we discussed is very clearly there over here. All right, guys. So this is the cos x graph, and this is how you can simulate the values using Excel. Okay. All right, guys. So next we'll move on to the graph of y equals cos x. So before you move on to cortex, it's always good to have a look at the reciprocal. So now cot is the reciprocal of tangent x. So this is the original graph of y equal tangent x. Right, guys? So this is what we do previously. Okay. Actually, even all these graphs can be simulated using Excel. Okay. All right. So you can see this is your tangent x graph. Okay. So I want to draw the reciprocal of this, right? I want to draw the reciprocal of this. So guys, again, you can see in this graph also, we need to check on this point. Why? You can see again, the original graph passes through x equals 0. And when you take the reciprocal, I mean, it passes through y equals 0. You are going to take the reciprocal of all these y values. So when you take the reciprocal of 0, it's going to give you an asymptote. So again, even in the cortex graph, y equals 0. Okay, at this point, at the point where you cut the y axis over here, this y value is going to give a asymptote, right guys? So this line, this point is entire line will be an asymptote. That's an important point again. Okay, so even the cortex graph, you need to check what happens to the graph as you, because you can see either side of the graph is existing. So you need to check what happens to the graph as you, the cortex graph, as x approaches the asymptote from the positive side and as x approaches the asymptote from the negative side. All right, guys, do you understand? So why I decided on the asymptote? So basically because the original graph pass through zero. That's the main reason. Okay, so we realize that x equals 0, I mean, is an asymptote. So for positive x, as x reaches close to 0. So what's going to happen? Okay, so what's going to happen? You can, give the values in the cal. So 1 over, cot is the reciprocal of tang. So it's 3 tang. So for positive x, as x approaches 0, so you can give a very small positive x figure, right? So 0 point maybe 001. Okay, you can make it small. So you can see it's it's positive, right? So if I add zeros here and make it more smaller, you can see it gets, I got 1,000, now it became 100,000. So it gets really large. The more zeros you add, the larger it gets, because the more closer you bring it to 0, the larger it's gonna get. Can you see, guys? The value gets larger and larger the more closer you come to 0. All right. So you can see here the cortex graph approaches positive infinity. Are you with me? So when you are considering the graph, all right. So when you are close to, now you know this line is an asymptote. So when you approach this line from the positive x side, when you come close to this line, the graph is large and positive. So you realize the graph is up over here. Okay, it needs to be up over here, and we need to see whether it comes down, cuts the line, or how it moves. Okay, how it behaves. And then guys, so let's do the thing properly now. Okay, so from this point, the next thing I check is what happens as x reaches positive infinity. So I'm going to check this part. Okay, this section starting from here, and what happens when x reaches positive infinity. Is this graph going to go down, or how is it going to behave? So when x goes to positive infinity, I'll do that next. Okay, so when x goes to positive infinity. So when x goes to positive infinity, guys, what happens? So what happens to the tangent graph, right? When x goes to positive infinity, we found what happens to tangent graph. I think we have it over here. Here, when x goes to positive infinity, tangent x graph reaches 1, right? It reaches 1. Tangent x graph reaches 1. So what happens to the cortex graph? So cortex is the reciprocal of tangent. So 1 over this value, 1 over 1. Now previously we were working with 1 over infinity, and that became 0. But 1 over 1 is simply 1. Because when you divide this, when you take the reciprocal of 1, it doesn't change anything. It's just 1. So basically you can see when x approaches positive infinity, guys, as x approaches positive infinity, your cortex graph is coming closer and closer to 1. So you need to realize that 1 is kind of like a, so this 1 is like an asymptote, right? Right, guys. So the graph as x is near 0, when x is close to 0, it was a large positive y figure. But when x gets large, infinitely large, the graph is coming close to 1. So I think you can see the way it should work out, right, guys? So the graph gets closer to 1. Right? It cannot pass 1 because you can see it's an asymptote. So the graph has to come in this manner, right? So you can always use extra points to check, and I will also show you the simulation from Excel. So you can always use the calculator, to see extra points. And then guys, now check the other side, right? So what's the other side? I want to see the other side over here. What happens as for negative x? Okay, so now for negative x, as x approaches 0. On the negative side, what happens as x approaches 0? Right, guys? So you can get that from the calculator. Okay, by giving a small negative x figure. So 1 over tangent of minus 0.001. So you can see negative 1000. So it's a negative figure, a negative y value. The more zeros you add, the more closer you bring it to 0. So it gets larger. Can you see, guys? So it's you can see for negative x as x approaches 0, the 1 over tangent or the graph is near negative infinity. Or the y values are infinitely negative and large. Okay, so then your cortex graph is infinitely negative. I mean negative and infinitely large. And then so then basically you understand as x is close to, I mean when x from the negative side, when x reaches close to 0, the y values are really large and negative. So that means it's down over here. Right, guys? So when you're close to 0 from the negative x side, right? Can you see the argument that I'm trying to make? This was the exact same thing I was using before. Okay, so when x is near 0, but when you're approaching from the negative x side, the y values are large and negative. Okay, and then we'll check the other side. What's the other thing now we'll check? You check what happens to the graph when x is going to negative infinity. So how will this happen? We know it starts from down here. So is it going to come up, or I mean, how is it going to move? So when x approaches, when x goes to negative infinity. So when x goes to negative infinity, guys, we know the behavior of the original tangent graph, right? We have it. When x approaches negative infinity, tangent x graph approaches minus 1. Can you see? When x approaches negative infinity, tangent x graph approaches minus 1. Okay, so cortex graph in that case, so it's the reciprocal of minus 1. 1 over minus 1 is again minus 1. Right, guys? So you can see that the graph is limiting at minus 1. So it can only reach as far as minus 1. Right, so that's it. So can you see, guys, the graph of vehicle cortex? So let's also do the simulation using Excel. I'm going to draw y equal cortex. Okay. So let's give the x values and the y values. The x values I will take okay, and then let's give the y value. So how does it work, guys? We know tangent. So you need to know the equation. So what was tangent? What is the equation of cortex? So we need to give the equation. So we have here tangent is e to the power 2x minus 1 over e to the power 2x plus 1. Right? So cortex should be the reciprocal of that. All right, guys. So e to the power 2x plus 1. I'll just write over here. Okay, cortex is going to be e to the power 2x plus 1 over e to the power 2x minus 1. Am I right? E to the power 2x plus 1 over e to the power 2x minus 1. So reciprocal. Right? So shall we give that? Okay, so let's give that here. All right, guys. So we give equal. So e to the power 2x, e to the power 2 times. So you give times Okay, 2 times x. So x in the sense you give the value here, right? So what's the value? This guy. E to the power 2x plus 1, right, guys? Plus 1. Right, guys? So can you see you need to make sure the brackets are given correctly. So open bracket e to the power 2x plus 1, close bracket, that one entire section, divide by, again, open bracket, e to the power 2x. So 2 times 2 times x is again this same guy, e to the power 2x, close bracket, minus 1. All right, guys. Right, so the bracket needs to be given properly. E to the power 2x plus 1 over e to the power 2x minus 1. All right, guys. All right, guys. So then you get one value. And then we get it with the entire set of values. Right, guys? Can you see? So again, you can see here we get the division 0 error, right? So that point, because you have an asymptote. So you remove that point. Okay, so remove that point. And then you get the xy values. You select them. And let's go for the graph. And we go for the charts. Right, guys, so you can again clearly see, right? So over here, even, I mean, you can see like, so the graph is limiting at 1, right? So that, of course, you need to know it manually. Okay, so you can see here, it reaches minus 1 and plus 1, right? So even though it doesn't show the line, the asymptote, you can see from the values, but you can, I mean, you need to be able to identify that from the main graph. Okay, so this is just a simulation to show you the shape. Okay, the proper shape, because I was drawing a sketch. So this is the simulation of the proper shape. Right, guys? So this is y equal this is cos x, right? This is y equal cos x. So actually you can see I've drawn, I did the 3 graphs, cos x and sech x and cos x, right? Okay, cos x and cos x. So basically you could even do the simulation. Now I did the sketches of, shine, caution, tangent, okay, but I didn't go for the simulation, but it's really easy to do that, right? So using this technique that I showed you, you can, I mean, if you want to like see the shape properly and exactly, you can easily get it done by using this kind of software. Okay, just to see the shape. But anyway, I think I have given you the shapes and all these things, so I'm not gonna go over there, right? So I think these were the 3 difficult graphs, so we went through them. Okay, so I went through them, the sketch as well as the exact shape by using this. Okay, guys. And then coming back over here, what about the range? Right, so what about the range of y values? You can see the graph, you can see the cortex graph is greater than 1, right? Because your y values are greater than 1, or the cortex graph can be less than 1, less than minus 1. Right, guys? It's not in between minus 1 and plus 1. In between minus 1 and plus 1, the graph doesn't exist. So you only have solutions for cortex values greater than 1, and you only have solutions for cortex value smaller than minus 1. That's it. All right, guys, are you clear? So those are the graph only exists within those ranges. I think if I went back in the previous graph, guys, over here, you can see we have for the range, I think you have, this is the positive graph, because I think I didn't discuss the range here. So you can see the y values are going to be existing. The y will exist for, I mean, you will have y for all the y values are existing except y equals 0, right, guys? Because at y equals 0, you have an asymptote here. Other than y equals 0, you have all the other, the range includes all the y values except y 0. All right, guys. So that's the range of the graph. So that I'm coming back to the cortex graph here. Okay, so you can see how it works, and this is really easy. So it's better to have the graphs in your mind so that you know when you see a function and if they ask you to solve, you can immediately, by knowing the shape of the graph, you know if there is a solution, and you know if there are multiple solutions, and you know if there is only one solution. So basically knowing the shape of the graph is going to be really useful for you guys. Okay. So I hope this part is very clear.